Ahaha. So sorry, my dear students. For reasons unknown to me also, and for reasons unknown to you, I regret to inform that today's class stands cancelled. You wish that was the news, nah? No, okay. That was fake news. That's how fake news travels, okay? So, be a responsible citizen and detect fake news and report it to the ministry, whatever ministry it is, okay? I forgot about it, okay? Next time I'll tell you the name of the ministry. So, fake news are circulating every now and then, so, okay, don't get duped by such fake news, okay? Don't get even duped by the fake news which a person like me, your teacher, tells you. So don't believe news, okay? Always check the authenticity of the news. So this is me giving you some valuable knowledge on how to live in a society, okay? So genuinely very important, and also truth be told, okay, this is happening around us. So many fake news being circulated in and around, so we have to be alert, okay? Alert raho. What is that called? Hindi, say Hindi in what we call it? I forgot, okay? Swatantra raho, something like that, okay? So, okay, forget about it now. Let's come back to our channel. So, hello, my dear students. My name is Benatang Paton, and I welcome you to the channel Classroom, where we learn together. Okay, so today the topic is combination of resistances. So, this is a very simple topic. Now that we are familiar with resistances, we know what resistance is, isn't it? We are familiar with resistances. So resistance is opposition to the flow of charge. Okay. So how do we draw resistances? In the previous class, I have already shown you how resistances are drawn. So resistances are drawn like this. This is the symbol for drawing resistances. Okay. Now I have drawn here three resistances. Resistance 1, 2, 3. Now, there are two ways to arrange resistances. Before I forget, you know what I'm about to tell you. So, grab your notebook, grab a pen or a pencil, and write down the notes, okay? Because this is going to be very much useful to you. So, there are two ways, okay? There are two ways to there are two combinations available for resistances, okay? Resistances can be combined in series and resistances can be combined in parallel. So remember, there are two combinations for resistances. So resistances can be combined in two ways, okay? They are series combination and parallel combination. Okay, in this video we are only going to learn about these two only, series combination and parallel combination in detail. Okay, so let's go in detail. Let me segregate this page in the middle and we will go in detail. So from where do I draw a line? I think somewhere here now. So let's draw a line from here and let's study, okay? What a perfectly straight line. So let's put this side series and this side is parallel. Side by side we will learn because this way it's easier to learn, okay? So in series combination, how do we arrange the resistances? In series combination, the resistances will be arranged like this. So we have the first resistance, so it will be drawn like this. Okay, this is the first resistance. Okay, from this point to this point. Then the second resistance will also be brought here, and then it will go like this. This is the second resistance, and then the third resistance will also be brought in, and then it will go like this. So this is how resistances are combined in or joined in series, okay, along a line. Remember, okay, along a line. So it's along a line, Such arrangement of resistances along a line is called series combination. Okay, it's called a combination because there is more than one. Okay, we have 1, 2, 3. 3 resistances are there. We can take more, but we'll not take more. 3 is enough. So there are 3 resistances taken here, and since there are more than one resistances, this is called combination of resistances. If it was only one, then it will be wrong to call combination, isn't it? But it is more than one. That's why it's called combination. Okay. So this is series arrangement. Okay, along a line. So this is 1 point. Okay, point 1, point 2. Then the second resistance shares the same point here, and then this is the other point. Then the third resistance shares the same point, like that. Okay, so these are all their points. Okay, next let's go to parallel. If series combination looks like this, how will parallel combination look like? So I hope you know how parallel lines are drawn. So parallel lines can be drawn either like this or like this. Which one are we going to take? We will be taking this one. Alright, so we will use 3 resistances again. So now see, point and point. Between the 2 points, okay, this is resistance 1. Okay, every resistance brings its own 2 points. So first resistance done. Then the second resistance will also share this one only. Okay, and then like this. This is how parallel combination looks like. Then the third resistance also will do the same thing. And this is how it is. This is how parallel combination of series of resistances looks like. Simple. Okay, so this is how parallel combination of resistances looks like. So we can call this to be R1, resistance 2, resistance 3, the same thing here, resistance 1, resistance 2, resistance 3. Alright, now let's complete the circuit. Let's bring a battery to bring potential difference. Okay, so long is plus minus plus minus plus minus. I told you a battery, draw at least minimum 3. Okay, and join it here. That's it. Let's do the same thing for here also. Long, short, long, short, long, short, and that's it. Okay, now just to give you some more insight. Okay, there can be many shapes. Okay, I'll show you some more here. So between the 2 points, so you are familiar with this one, but this also can be, this also can be. Okay, as long as it's between the 2 points. I hope you're getting my idea now. This also is parallel only. Okay, because it's happening between these 2 points only. Okay, the 2 points are common. The 2 points are common for all of these resistances. So this is how resistance in parallel may even look like. So don't just think that this is how the figure should look like. No, this is a misconception. The figure can look like this also. So how do you detect? You always identify the 2 points. Okay, the 2 points of the resistor. And so parallel can even look like this. Okay, this is summer season, and then mosquitoes are brewing in my own room. So now when the resistances are arranged along a line, okay, this is called series combination. And the resistances, when the resistances are arranged, okay, like this is called parallel combination. Okay, now next, this is a battery. Now some very important differences between series and parallel, which every student should know. Okay, there are some points of difference between series combination and parallel combination. Let's study them now one by one. So this is the battery here. Okay, now what does the battery bring? A battery will bring a potential difference, isn't it? So let's say the potential difference of this battery is, say, 6 volt. Okay, now this is in series combination. Now first of all, let us study what is constant in series. So what is constant in series? So constant in series, what is constant? In series, what is constant? Now let's see. So remember this, my dear students, in series combination, the same current flows throughout the system. That means current remains constant throughout the system. So current remains constant. What do I mean by that? See, so there will be current flow here. Let's say the current is I. Okay, let's just take I, capital I. Okay, I is a symbol for current. So current I is flowing here. So current I will flow here also. Current I will flow here also. Current I will flow here also. And current I will flow here also. Current I will flow here also. So everywhere current I is flowing. Okay, everywhere current I will flow. That is why current is constant in series. Remember this. Alright, now to make it more easier for you, we are discussing these three quantities only. VIR, Vir. In Hindi, Vir means brave, is not Vir. So take this out of the discussion because he is already here. Okay, they are already here. So take him out of the discussion. Okay, don't pay attention to him. So you have only two quantities to worry about: potential difference, which is V, and current. Okay, so the discussion is about these two only: potential difference and current. So in series combination, current is constant. That means the same current flows throughout the system. For example, if 12 amperes of current is flowing here, then 12 amperes of current is flowing through R1 also, through R2 also, through R3 also. That means throughout the entire system, 12 amperes of current is flowing. That is the meaning of current being constant in series. But something is getting divided in series. So who is getting divided? So somebody is getting divided here. So who is divided? It will be this fellow. No. It has to be this. Okay. So if current is constant, that means potential difference is getting divided. So what gets divided in series combination is voltage or potential difference. So voltage, you can write voltage, or you can write potential difference, because they are the same thing only. So potential difference is different across R1, across R2, across R3. So here I have given you the potential difference which the battery is giving. Okay, it's 6 volt. But since potential difference will be divided, we can assume that here it is 1 volt, here it is 2 volt, and here it is 3 volt. Okay, potential difference, voltage, gets divided. Current remains constant. So current does not get divided. The same current will flow throughout the system, whereas potential difference gets divided. So potential difference across these 2 points, okay, will be different. Potential difference across these 2 points will be different. Potential difference across these 2 points will be different. So we're assuming it to be 1, 2, 3. All together, on joining these 3, you should be getting the overall potential difference which the battery is giving out, which is 6 volt. So do we get 6 volt? 1 plus 2, 3. 3 plus 3, 6. Yes, we get 6 volt. So this is how we study series combination. So remember, my dear students, this is very important. This is very, very important. Okay, you just have to know this one. This is very important. This is very important. You have to know this one. Okay. So there are 2 ways to combine a resistance, series and parallel, and then you have to understand what remains constant and what gets divided in both the combinations. Now we move to the parallel combination, and to make it easier for you, the opposite will happen in the parallel combination. Alright, so same thing. Okay, we will use the same voltage, so we'll use 6 volt. Okay, now what remains constant and what gets divided? So this is, the quantities are the same. It's between voltage, current and resistance. But like I said, since resistances have already been addressed, rule him out of the discussion. Okay, we are discussing about resistance only, so he is already in the discussion, so rule him out. It's between voltage and current. Now if you have understood series, then just do the opposite of what you have done in series. Okay, in series current was same, so in parallel combination current will not be same. That means current will not be constant. Okay, current gets divided. So current will get divided. Okay, this is if you have understood this one. Okay, you can rely on this information to easily understand this one. So so current is constant in series, current gets divided in parallel. I told you now opposite will happen. And potential difference, which is voltage, gets divided in parallel. Voltage will be same in, voltage will remain constant in parallel. So voltage or potential difference will remain same in parallel combination. Okay, let us discuss in detail. So potential difference remains constant. So the potential difference given by the battery is 6 volt. That means 6 volt will flow throughout the entire system. Okay, so 6 volt will flow through R1, R2, R3. So between this point and this point, 6 volt will flow. So 6 voltage will flow throughout the entire system. That is the meaning of constant. Okay, that is the meaning of constant. Current gets divided. Let's understand this one. So let's say current I, okay, comes out of the battery. So the same current I will reach till here, but after reaching here, current gets 3 ways to divide itself. So a part of the current will flow through this path, then the other current will then a part of it will pass through this path, and a part of it will pass through this path. See, 3 paths are available for current to pass, is it not? So current will distribute itself, current will divide itself into the different paths. So let's say I1 goes here, I2, current 2 goes here, and current 3 goes here. So on this path, through R1, I1 is traveling, through R2, I2 is traveling, through R3, I3 is traveling. And all of them will come and then they will meet again here, and then they'll get back and they'll become I again, the total current again. And then the same current will find its way to the battery again. Understood? Once again, current I comes out of the battery. From here, current gets divided into three parts because there are 3 routes for current to travel. I1 goes to R1, I2 goes to R2, I3 goes to R3. Again, they join again because the road is 1 again. So they join back to become the original I, which is here. And then the same I will flow back to the current. So current divides, okay, across R1, R2, R3. Just like potential difference got divided across R1, R2, R3. In parallel combination, okay, in parallel combination, current divides along R1, R2, and R3. So mosquitoes getting inside my room because the window is kept open. Okay, so this is it. I hope you understood. Okay, so please understand this one. Okay, and then we will go for derivation now. Okay, this is it. All you have to understand in this is that what remains constant and what gets divided. All right, so I'll erase this one and we will do a very important discussion, a very important derivation which comes for 3 marks. So I'll teach you, okay, a 3 mark derivation. Okay, so let's derive the equation. So let me erase this one also. So let's write down the question. The question will be derive an equation for the combination of resistances in series. First we'll do this one. Now this is very easy. Okay, so I'll tell you the trick. Okay, how this is very easy. It's very easy, okay, to do this. The trick is always start from the quantity which gets divided. Now, in which combination are we in? We are in series combination. Now try to recollect what I just told you earlier. In series combination, which quantity gets divided? Is it not voltage? Yes, it's voltage, isn't it? So you remember the diagram? The diagram was somewhat like this. we have to draw the diagram also, okay, for this derivation. So at least draw a diagram like this. So the voltage capital V, the total voltage of the system gets divided into three parts, okay, V1, V2, V3 across R1, R2, R3. All right, and the same current flows throughout the system. So that too we already know. Current remains constant. So the one who remains constant, we don't discuss about it. We discuss the quantity which gets divided. So we will start with this. So always start with the quantity which gets divided. The same you will do for parallel also. So how to derive? So derivation, okay. So start. So V, okay, here V gets divided. So V for the system, okay, V for the entire system, okay, V for the entire system gets divided into V1, V2, V3. So the sum of V1, V2 and V3, will it not give me the final V? Yes, V1 plus V2 plus V3. If you remember earlier, before I erased the figure, I wrote here 6 volt, yes or no? And I wrote here 1 volt, 2 volt and 3 volt. So 6 volt is this one, and then V1 here is 1V plus 2V plus 3V. It will give me 6 volt, it will give me 6 volt. Basically this is what we are doing, okay. If you are still confused like what is this, what is going on here, then this is what is going on here. All right, the total voltage of the system, since voltage gets divided across R1, R2, R3, at the end they have to add up and give the total voltage of the system only. So on adding this V1, V2, V3, they will give you the total voltage of the system. But in the derivation, we don't write these things. Instead of these things, we're writing V1, V2, V3. So understand that V1 is this one, V2 is this one, V3 is this one, and on adding this will give you 6, because the total voltage of the system in that example which I took was 6 volt. So you have to understand this. All right. So now after this, what you will do is we will use Ohm's law. Using Ohm's law, we will use Ohm's law on this, on this, on this, on this. So if we use Ohm's law on this one, what we'll get? Ohm's law is V is equal to IR, na? V is equal to IR. So instead of writing V, I can write IR or not. Yes, after all, Ohm's law is V is equal to IR, isn't it? So I'll not write V anymore. Instead of writing V, I'm going to write IR. Okay. This I is the current for the entire system, and this R will be the equivalent resistance. We are going to find the equation for combination of resistance. Derive an equation for the combination resistances in series. We are going to find the equivalent resistance for this combination, okay? The total resistance, the formula to find the total resistance for this system of combination. So we have written V. Instead of writing V, we have written IR using Ohm's law. For V1, which means this one, for this one, it will be IR1, because here the resistance, we are talking specifically about V1. So V1 has got its own resistance, which is R1. Okay. Then for V2, it will be capital I. For V2, its resistance is R2, because V2 is the potential across R2, na? And for V3, it will be R3, because V3 is the potential across R3. Any doubt? Any confusion? No, na? Okay. Now, here is an observation which some of you will be making. Sir is taking R1, R2, R3, alright. But why is Sir taking I? Why not I1, I2, I3? Okay, that is a very good observation which you have. Now, let me tell you why I am taking I. The reason I am taking I is because, now you tell me, in both types of combination, there is a quantity which gets divided and a quantity which remains constant throughout the system. In series combination, which quantity remains constant? Yes, very good, current. That's why, since current remains constant across the entire system, the same current flows across R1, the same current flows across R2, the same current flows across R3. So that is the reason why I'm writing I. If they got divided, I'll be writing I1, I2, I3, which I will do in parallel. but this is series combination. In series combination, it is potential difference which gets divided. That's why I'm writing V1, V2, V3. The quantity which gets divided, we write we write in the form of V1, V2, V3, I1, I2, I3. Understood? So here, nothing to do, just write like this. Here, take I common. If you take I common, you are left with R1, R2, R3. Cut I, R, you'll get R1 plus R2 plus R3. This is it, my dear students. How easily we have derived an expression for a combination of resistances in series. Okay, this is the formula to find the equivalent resistance if the combination is in series. So the total resistance of the combination, the total resistance of the system will be the sum of R1, R2, R3. So if R1 is 1, this is 2, this is 3. Or if this is 10, 10, 10, it will be 10 plus 10 plus 10, which will be 30. Okay, simple addition. In series combination, all you have to do is add the individual resistances. That will give you the resistance of the entire combination. This is not me just saying it. This is the formula telling us to do that. Okay, so this is the formula. Okay, have you understood this? Okay, this is an easy one. Okay, no need to panic on this. This is easy. Okay, now we go to parallel. So the question will be derive an expression for the combination of resistances in parallel. So like I said, these are 3-mark questions and these are very easy. So I don't want you to miss out on these questions. So I want you to score the 3-mark which your teacher at school will give you if you attempt this question. So don't let those 3 marks go away, okay? So whatever we did here, we will do the same thing. This is a parallel combination. How do we start here? We started with the quantity which got divided. The same thing we'll do here. Which quantity gets divided in parallel combination? V or I? V already got divided here. So which quantity gets divided here? Yes, current. So current gets divided. So how do we start? We start like this. Current is equal to I1 plus I2 plus I3. Yes or no? So let us draw the figure. So these are the 2 points. This is R1. Afterwards, I'll name R1, R2, not now. Declaring anything too early, sometimes we go wrong, okay? So always take your time to declare. Don't always hurry to declare, because those who hurry, they make mistakes, okay? Be slow, but not too slow also. So this is R1, this is R2, this is R3. So this is current. Current is I here, and the potential difference is here. Now you know that potential difference remains constant throughout the system. So we will not take potential difference, but it is the current which gets divided into 3 parts. So current here will be I1, current here will be I2, and current across R3 will be I3. Why is current dividing? Because there are 3 paths for current to travel. So from this point, current will divide into I1, I2, I3. Later on again, it will join back and reconvert to I again. So that's basically what I'm writing. Capital I, which is the current for the system, is I1 plus I2 plus I3. So I1, I2 and I3, they will join and give you I again. Alright, the same I got divided into I1, I2, I3, and I1, I2, I3 will join again and give us I again. Understood? So simple, nah? Okay. So now what you do? Do the same thing. Copy paste whatever you have done using Ohm's law. Using Ohm's law. Using Ohm's law. Using Ohm's law. Now, Ohm's law is like this. V is equal to IR. Here, we need the formula for I. So let's make the formula for I. So I is here, keep him there. V is there, keep him there. R goes below V. So the formula for I is V by R. So instead of writing I, you write V by R. Okay, V, the potential difference for the entire system, and R, whose formula we are going to find. R is the equivalent resistance for the combination. I1 will be, since it will be VR1, voltage remains same. Okay, I2 will be, I3 will be, yes or no? This is how it will be, isn't it? Okay, the voltage remains same, resistances are different, R1, R2, R3. Okay, formula is like this only, V by R. So what do you do? Take V common because V is same. Okay, if you take out V, then you are left with 1 by R1, R2, R3. Alright, cut this V, cut this V. You are left with 1 by R is equal to 1 by R1, R2, R3. This is the formula for finding the resistances if the resistances are combined in parallel. So easy. And some of you were thinking that it was so hard. Okay, so if there is any student, okay, who thought it was hard, okay, kindly watch this video and tell me after watching this video, was it that hard? I believe not. Okay, I believe not. Okay, it is not that hard. It is so simple. How can you say this is hard? Okay, the concept is very simple. Just remember these quantities V, I, and R. Okay, and remember which quantity changes, which quantity remains constant. We always start for deriving this derivation. Always start with the quantity which changes. So for series, it is V which changes. So we start with V. For parallel, it is current which changes. So we start with current. That's it. That's it. And use Ohm's law. You get the answer. Automatically, the steps will give you the answer. So this is it. Okay, my dear students. Today's video is about this only. Okay. So here we have learned the two types of combination: series combination and parallel combination, along with the derivation. Okay, which are 3 marks each. So this class is gonna fetch you quite some marks in your exam. Okay, so go and write the exam and score good marks. That's what I want you to do. So as usual, before I leave you, question for the day. So question is, which quantity remains constant? I'll not say constant. I'll just ask changes. Remains. Which quantity changes? Not remains. Which quantity changes? Or you can say divides. Okay. In series combination. Kindly answer in the comment box. Where else will you answer, isn't it? Nah? It's so silly of me to ask, isn't it? Nah? You sir also, nah? You must be thinking, use common sense, nah, sir? Yes, that's true. I should use my common sense, because where else can I tell you to answer except in the comment box? So kindly answer the answer, whether it be right or wrong. It's okay. Just participate and answer in the comment box. So thank you all, my dear students, for tuning in and learning from me. Thank you all for the support so far. May God bless you all, and I will see you again in the next video.